Rare earths, the new weapon of power. The phone in your hand, the car gliding silently through the streets, the wind turbines spinning offshore, even the satellites orbiting above. All of them depend on elements most of us have never named. They are called rare earths, not rare in quantity, but rare in terms of control. In the age of energy transition and technological race, power is not only in oil, gas, or coal. It is also hidden in small grains of metals, extracted with difficulty, embedded in powerful magnets, glowing screens, navigation systems, fighter jets, nuclear reactors, and almost every smart device. Rare earths are 17 elements on the periodic table. They create properties ordinary materials cannot. Rare earth magnets are smaller yet far stronger, making electric motors compact. Some elements brighten the colors on your screen. Others catalyze oil refining or reduce emissions. Without them, clean energy slows down, defense industries weaken, and artificial intelligence lacks the best hardware to operate. That is why a material everyone needs becomes a weapon of power. Power does not only come from mines. Power comes from refining and magnet production, from technology, environmental standards, capital investment, and the supply chains that surround them. Many countries have mines, but very few are willing or able to pay the environmental price of extraction. Refining rare earths is a long journey of separation, leaching, washing, and filtering, with heavy use of chemicals and energy. Whoever controls this step holds the upper hand. Once, the largest mines were in the United States. Then, because of costs and environmental burdens, refining shifted to places willing to do the dirty and difficult work. When technology, labor, factories, and supply networks concentrate in one location, advantage accumulates over time. It is not just about having plants, it is about experts, processes, standards, clients, logistics, finance, and favorable policies. That is the historical inertia of supply chains. Once formed, breaking it costs years and billions. Power is visible through two mechanisms. First, choke points. If refining and magnet making are concentrated in a few countries, a change in licensing, export quotas, or standards can shake global markets. Second, prices. When supply is squeezed, costs soar, and industries from EVs to wind turbines pay more. The controller of supply does not need to shout. A single government notice can rewrite the plans of multinational corporations. Think of three overlapping layers of power. The first layer is resources. The second is refining and magnet production. The third is knowledge ecosystems and standards. The first gives you entry. The second gives you the key. The third gives you the whole building. When all three concentrate in one place, the short-term advantage is nearly absolute. Even countries with mines still send ore abroad and depend on others to complete the value chain. The world wants to be greener. Renewable energy needs rare earth magnets. EVs need high-efficiency motors. But mining and refining rare earths puts pressure on land, water, and local communities. We face a paradox. To reduce global emissions, we may worsen local pollution, unless cleaner extraction technologies truly take off. When one country shoulders the dirtiest parts while others reap the benefits, the moral balance of the entire system comes into question. Responsibility cannot simply be outsourced. It must be shared through common standards, cleaner technologies, and capital large enough to make the right thing profitable. The US, Europe, Japan, Korea, Australia, and others have pledged to diversify supply chains. Mines are reopening. Magnet plants are funded. Recycling is being pushed since e-waste holds vast amounts of rare earths. Engineers are even designing motors that need fewer of the scarcest elements. But all roads hit the same wall: refining. Building this capacity cannot be done overnight. You cannot rush chemistry, environmental safety, or skilled labor. You cannot fast-track community agreements, permits, or logistics either. Behind a small magnet lie big political decisions. Who gets licenses, subsidies, and tax breaks? How carbon taxes treat imports from places with low standards? Whether to impose barriers based on pollution intensity in the supply chain? If yes, green products become more expensive, and consumers react. If no, dirty refining remains cheap and attractive. This is the global cost-benefit allocation puzzle. There is no perfect answer, only less harmful choices. Scenario 1. The world accepts some dependency and manages risk with reserves, long-term contracts, and diplomacy. Scenario 2. Industrial powers pour capital into domestic or allied refining, paying more for security. Scenario 3. Technology advances quickly enough. Large-scale recycling, clean extraction, or new material designs reduce rare earth demand. Likely all three happen together, weighted differently by region and industry. Do not just ask where the mines are. Ask where the refining is, where the magnet factories are, where the material labs are, where testing standards are set, and where financial networks are ready to take risks. Treat supply chains as ecosystems. If you want rapid growth, you must plant seeds at many points. Mines provide raw material, universities provide people, factories provide capacity, regulations provide trust, and capital provides speed. Miss one link and the whole ecosystem breaks down. The story of rare earths is not just about winners and losers. It is also about what kind of world we want to live in. A world green on paper but dirty elsewhere, or a world willing to pay the true cost of cleanliness. Communities near mines, tailing ponds, and refining plants deserve a voice, fair benefits, and a share of profits. Justice does not appear automatically. It must be written into contracts, laws, technical standards, and the way value is shared. Picture a small magnet resting in your palm. Tiny, almost harmless. Yet its pull drives entire economies forward. Its invisible force lies in government policies, corporate strategies, consumer choices, and humanity's dream of a cleaner planet. Rare earths are not just elements on the periodic table. They are a test of human intelligence and maturity, of how we balance growth, security, and ethics. If the power of the last century lay in barrels of oil, the power of this century may rest in unseen metal dust. What happens when those dust particles change their flow? Will we pay the real price for autonomy and sustainability, or take the shortcut and pay later? Which path should the world take, and who will be brave enough to pay first?